Yesterday we focused on domains. We spent a lot of time on that, and then we talked about operations with functions. Okay. Today we're going to talk about composition. So we're going to be building new functions by putting a function inside of a function. And then I wanted to put this on here. Our next lesson, which is going to be next Tuesday. You guys have Friday off and then Monday off. Okay, next Tuesday, we will do a review of operations and compositions with functions. And then we're going to do a homework quiz. That homework quiz will be a take-home quiz. So it's going to look a little bit different, but it will be a take-home quiz over what we've been doing these last few lessons. Okay, first thing that you're going to write down is this. This is our notation. So composition of the function f with g is denoted f, and then it's like a little open circle, and then g. The equation for that looks like this in yellow. So I'm going to use red for my f and g for my green. Okay, so what I want you to notice here is that I have my function f right here, but inside of my function f, what do I have? The g. Like we are literally taking our function for g and putting it inside of f. Okay, that's what we're doing. Sometimes it's going to be like an actual number. Like we're going to run a value through the function g, and we're going to get a new value, and then we plug that into function f. Okay? Other times, we're just simplifying the two. We're going to put the g of x into the f of x, and then we simplify by combining like terms and distributing and all of that. Okay? So this is our first example. Now, I'm going to tell you with this stuff today, if you don't write the top stuff, like this stuff right here, the rest of your notes aren't going to make much sense. So you have to write what the original functions are. So this first one, I like to rewrite this in that equation notation like that. That's f of g of 3, because I like to see that, hey, I am starting on the inside. I have to do g of 3 first. I cannot do f of g if I don't know what g of 3 is. So I have to go grab my green function, my g of x. In this case, we're using 3. And I'm going to say g of 3 equals, and then everywhere that I see an x, I'm going to put a what? 3, yeah, because usually inside this parentheses we have an x, right? It's usually g of x. Well, we've just substituted 3 for x. So I'm going to put a 3 in here. So it's 3 squared plus 3 times 3 plus 4. And now we just do the math. 3 times 3, 9, and then plus 9. And then plus 4 is 22. So I know now that g of 3 actually equals 22. So now I know what this value is in the middle. Now I know that this right here, g of 3, is actually equal to 22. Right? So now what I can do is take that 22, and I'm going to plug into my f function, my f of x. So it's going to be f of 22 equals, and then everywhere that I have an x, I'm going to put 22. Usually I like to do this. So you can see where I got that 22 from. It came from that green step. Visual here is what we're doing. If I look at this notation right here, I am taking 3 and plugging it into my g of x, and then whatever I get there, I'm plugging into my f of x. Okay, if that helps you visualize that. So now we're going to do our math down here. 3 times 22 is 66, minus 8 is 58, right? So then f compose, and I'm going to write it in the original notation. So f compose g of 3 equals 58. Okay, the next one is the similar task, but we're going the opposite direction, right? So now it's going to be g of f of x. So now I have to use my f function first, right? So we're going to start with the red. Then what we get with the red, we're going to plug into the green. I'm going to give you 90 seconds to try that on your own. So g of f of x. You have to plug it into the f first and then the g. What do we get for the f of 4?
I got 32.
3 times 4 is?
Oh, wait.
12. Minus 8 is? 4. So we get 4 again. So then in my g of function, I'm going to just put a 4. Remember that this 4 right here came from our previous step. I don't know why I put that there. I think it's from a future problem. It should be squared. So 4 squared is 16, and then plus 12 plus 4. 16 and 4 make 20, plus 12 more is?
16 and 4 make 16.
16 and 4 make what?
Or 12 wait.
16 plus 4 is 20, plus 12 more is? 32.
Is that your final answer for g times f of x?
Yep, it's not times. It's g compose f.
Oh,
If it was times, it would be a filled in dot. So yes, g of f of, and it's of 4 equals 32. Okay, here's another set. So now I have x plus 3 for my f function, and x squared plus x minus 1. Okay, so we're going to do f of g of x, but then g of f of x. Now, what's different about this one compared to the last one we did? What did we have in the parentheses here? 3 and 4, right? We had numbers. Now what's in the parentheses? Just x. Okay? So what that means is we're going to take the other function and just replace x with that function. Okay? So this first one is f of g of x like this. So I'm going to take this whole thing right here, and we are going to put it right there in place of x, is what you're doing. So we have, then it's x squared plus x minus 1, and then we still have the plus 3, right? I still think it's good to put this in parentheses, even though on this you don't have anything to distribute. Sometimes it's important. But then all we have to do is combine like terms. So our final composed function is x squared plus x plus 2. Okay, let's do the next one. Next one's a little bit different, because now I'm going the other way. I'm taking my f of x function, which is x plus 3, and we're going to plug that into there. What's different here is that that value, remember that's going to be in parentheses, right? Put this x plus 3 in parentheses. So it's going to be that value squared. I'm going to do this one on the right side just so I don't run out of space on the bottom. So we're going to do x plus 3 in parentheses. That's my f of x. And then it's still squared plus, and then I have to do x plus 3 again. And then we have the minus 1. Okay, so now this is an area where some of us, I think we've done this. Can we do that? No. Okay, if it was this 3x like that, then we could, because it's multiplication in there, right? But it's not. We have that addition in there. So what it is it's that whole value squared. So this is where I have to take that and basically like put it under on the copy machine. So x plus 3 plus x plus 3 minus 1. So what we did is we took this right here and we made it into this. Because there's two of them. Now we have to FOIL that out. So x times x gives me x squared, and then I have plus 3x plus 3x plus 3 times 3 is 9. And then I still have the extra stuff here on the end. So now we've just turned that into that. You feel okay about the highlighted part? Now we just combine like terms. So we end up with x squared, and then plus 3 plus 3 is 6, plus 1 more is 7x, and then 9 plus 3 is 12, minus 1 is 11, so plus 11. That's our final function. Okay. We are going to skip that one for the purpose of time, and we're going to get to this, the domain of these, okay? And this top part, I don't even want you to read. It just makes it really confusing. I don't even really like it, okay? And I want you to do this bottom part. So on the bottom part, we are talking in terms of f of g of x, okay? Remember that that is f composed g of x, right? Those are the same thing. So then what we need to know here is that g of x creates a restriction, but also the f of g, which is this part right here, okay, which is like our final function. Okay, so this is the first one. We're just going to practice here on this one. We're not going to worry about domain yet. So it's f of g of x, f composed g of x, however you want to read it. So I'm going to take my g of x, which is this one right here, and we are going to put that in for x right there. The thing that should raise a red flag on this one is, we're going to have a variable in our denominator. I want you working on the composition. What would it look like if we compose these together? There's our function inside the function, the green part inside of the red part. Is there anything for me to distribute? Nope, there's nothing really to do with that green part. So we're just going to combine like terms. So that is going to turn into 4 over 4x minus 3. So that's our final composed function. Now we have to talk about domain. Domain, remember, is what can our input be? What can x be? Okay? And we cannot use an x value that is going to result in a negative number inside a radical or a 0 on the bottom of a fraction. You can't have those. Okay? So we start for the first part. Okay, and I'm going to try to do this so we can see both here. So we did the f of g of x, right? The first thing we have to start with is the original function that we put into the other function. Another way to think about this is like, which one would we start with? If we had a value for x, which one of these would we start with? We'd start with g of x, right? Because it goes like this. Boom. So we have to check g of x first. So g of x is our green one. So it's circled right here. Are there going to be any limits to that function? Are there going to be any excluded values? Do we have division anywhere? No, we don't have a division. We don't have any variable in the denominators. Nope, we're good. Okay, what about square root? Are there any square roots here? No? Okay, so for that green one, for g of x, our domain is negative infinity, infinity. So no limits so far. But for our new function, which is the one over here in blue, we have a variable in the denominator, right? So that's going to present a restriction, an excluded value. So I'm going to take the 4x minus 3, and I know that because it's on the bottom of a fraction, it cannot equal what? Cannot equal 0. So we're going to set that up like that. Now I add 3. Add 3. 4x cannot equal 3. Divide by 4, divide by 4. So x cannot equal 3/4. But we want to write that in interval notation like we started practicing yesterday. This is where we're going to use our unions. Okay, so our train takes off from what? Where do we start at? Negative infinity. Yep, we're pretty much always, when we do this, going to start with negative infinity. Okay, and it has to stop where? 3/4. Has to stop at 3/4. Is 3/4 a possible solution? Nope, so we use a parenthesis. Then I'm going to put my union between it. Then it takes off again from where? 3/4 and continues to infinity. So that's what our domain for this new function would be, for this composed function.
What was the question?
What do we have in this next one? Yeah, we have a radical, right? So that should raise a red flag. Oh, we're probably going to have an excluded value here. So I have a radical. So then this is f of g of x. So I'm going to take my radical 1 minus x, and we are going to put that in here. So for some of us, it might be good to actually go over and think about the domain right now before we go and combine anything. Let's think about what we're starting with. We're starting with g of x, right? Is that going to have a limit? It is, because we have that radical. So I know that underneath that radical is 1 minus x, right? That 1 minus x has to be greater than or equal to what? 0. Has to be bigger than 0. Okay? Like in total, because I cannot end up with a negative number inside the radical. Now I solve this. I'm going to subtract 1, x is greater than or equal to negative 1. That's actually a negative x, but I have to divide by a negative, so I have to flip my sign. So x has to be greater than or equal to 1. Okay, so that's for my g of x. Okay, that's my domain for my g of x. Now let's go back and put g of x into f of x. So I'm going to take my square root of 1 minus x squared plus 4. Remember, the green part is the g of x. The red part is our f of x. Hey, what's going to happen with that squared and the square root? It's going to cancel. Yep, so that's gone, and now that's gone. So I have 1 minus x plus 4. So my composed function is going to be f composed g of x is equal to negative x plus 4. Is negative x plus 4 going to have any limitations? Is there any number that I can't put in there? Do you see any division? Do you see a radical in the blue? No, so it does not have any limits. Okay, you could put any number you wanted in there, and it would be fine. Into our composed equation, okay? Malaya. Thanks, Word. Yep. Okay, should be a 5. Okay, now let's go write our domain, because we figured out the blue doesn't have any limitations, so the only limit we have was our original function, g of x. So now let's write this in interval notation. Okay, so can it be negative infinity? It says less than. X can be less than 1. So could it be negative 75? Is that less than 1? Yep. Could it be negative 7,482,000? Yep. Okay, so it can go all the way to negative infinity, and then it has to stop at what? 1. Could it be equal to 1? Yep, so we use a what? A bracket. So that is our domain for this composed function. And that comes from like the root function, the beginning function. What other questions do we have?